In this lesson, we are going to learn how to solve quadratic functions using the quadratic formula. You will notice when you come to the classroom tomorrow that the quadratic formula is above my smartboard. It is probably the most center formula in our room because we will use it the rest of the year for tons and tons of problems. The nice thing about the quadratic formula, as you can see, hopefully you can see the formula on the right hand side of the screen here, and you've used this before, you did this in intermediate algebra. The nice thing about this formula is that it solves everything. So we talked about in a few videos before about how the imaginary, sometimes we'd have no real solutions for an answer. This formula will solve imaginary solutions also. So just like completing the square, which solves everything, this one is a little bit easier to maneuver, and this is what I call the solve all. Anytime you need to solve a quadratic equation, this formula will work for you. It might not always be the fastest way, but it will work every time. So if you would choose to, you could solve every quadratic using this formula. You'll notice it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We are looking at a, b, and c in standard form for a quadratic equation. So for number 1, we would get our equation equal to 0 first before we could label a, b, and c. So now that I have my equation in standard form, I'm going to label a as 1, b is negative 12, and c is negative 28. From there, it's what I call plug and chug, which means I am just plugging this into the formula. You don't have to memorize this formula. This is not one that I will cover up for a test. I think you will naturally memorize it because you'll do a lot of these, but it's not one I require you to know. So you'll always have that available to use on the test. So it's x equals, and we'll do, it says the opposite of b, and that would be our b is negative 12, so we'd put a 12 here. Be really careful with that, because a lot of times that's where a common mistake is made, is having a sign error there. And then I'd say it's what plus or minus the square root of b squared. This negative 12 needs to be in parentheses, because I will be squaring the negative. This number should always be positive once you square it, and that's another common mistake that's made. And then minus 4 times a times c, so minus 4. That 4 will always be there. This will never change. It will always, always, always be a 4. That's part of the formula. Times a, which is 1, and times c, which is negative 28. All of that divided by 2 times a, so 2 times 1. From here, all you're doing is reducing this equation using your order of operations. So you're going to first simplify everything that is under the radical. So as I keep moving here, I'd say x equals 12 plus or minus, and I'm going to go ahead and say what's negative 12 squared, 144, and then I would have a negative 4 times 1 times a negative 28. So that would be a positive 112. Then on the in the denominator, I would have 2 times 1, which is 2. As I continue to solve this problem, I'm going to add under the square root, so I'd have x equals 12 plus or minus the square root of 256 over 2. You would try to see if 256 is a perfect square, and it is, right? The square root of 256 is 16. So I replace that root 256 with a 16. Now, from here, I remember we're supposed to have 2 answers for quadratics. So one of my answers is x equals 12 plus 16 over 2. The other is x equals 12 minus 16 over 2. So as I continue to simplify this, I'd get x equals 28 over 2. So x equals 14. And I get x equals negative 4 over 2, which would be a negative 2. Those are my 2 solutions for my problem. Could I have solved this problem using factoring? I sure could. That would always work. But I'm going to practice all of these using the quadratic formula. And these work for ones that would not work for factoring also. Just to show you the graph of this picture, we know that since our answers are 12 and negative 2, our graph should cross the x-axis at 12 and negative 2. Here's negative 2. Here's 12. So it does indeed cross the x-axis at those 2 roots. Number 2, same idea. We have our equation. We need to first get it into standard form, so I'm going to minus 33 from both sides. I have x squared minus 8x minus 33 equals 0. I'm going to go ahead and label my a, b, and c. A is 1, b is negative 8, c is negative 33. So as I substitute that into the formula, I would say x equals the opposite of b. B is negative 8, so I'm going to put 8, plus or minus the square root of b squared. So negative 8 squared minus 4 times 1 times negative 33. All of that over 2 times 1. From here now, I'm going to reduce this. One thing I want to point out is notice that this divisor here, this dividing bar, goes over this 8 also. It's divided by the entire numerator there. It's not just over the square root, it's over the number in front too, that negative b part. So make sure you're extending that line. So I'd have 8 plus or minus the square root of, I have 64, because negative 8 squared is 64. Negative 4 times 1 is negative 4. Negative 4 times 33 would be a positive 132 over 2. As I keep going here, I would then add under my square root, I have 64 plus 132. So I get 8 plus or minus the square root of 196 over 2. Hopefully we know that the square root of 196 is 14. So again, I got a perfect square again, right? These are two examples, the last two we've done. They both are perfect squares. So I have 8 plus 14 over 2 and 8 minus 14 over 2. When I reduce that, I would get x to equal 22 over 2, or 11. There's one of my roots. The second one then would be 8 minus 14, so negative 6 over 2, which would be a negative 3. So my two roots, my two solutions, my two zeros for this problem are 11 and negative 3. Again, if we want to go back up and check our graph, we will see that our graph crosses the x-axis at negative 3 and 11. Number 3 then. This one is already in standard form, so the equation equals 0, so I'm just going to go ahead and identify a, b, and c. A would be 1, b would be 22, and c is 121. So I'm going to copy into my formula x equals the opposite of b, so negative 22 plus or minus, I would have b squared, which is 22 squared, minus 4 times 1 times c. So I'm just substituting those values in, divided by 2 times 1. As I continue to reduce this, I'd get negative 22 plus or minus the square root of. 22 squared is 484. And then I have a negative 4 times 1 times 121. So it's going to be minus 484 over 2. Hopefully you're noticing that this is a little weird under my square root. I have 484 minus 484, which is 0. What's the square root of 0? 0. So I have plus or minus 0, which really is not going to make much of a difference. I don't have a positive or negative 0, so adding nothing isn't going to change the problem. So I would have x equals negative 22 over 2, or negative 11. The problem with this is that I'm supposed to have two answers, right? Because this is a quadratic equation. So let's think of this graph. If this parabola only crosses the x-axis at negative 11, what do we know about it? Hopefully you realize that's where the vertex is, right there at negative 11. So remember, we call this a double root, where our vertex is. If we would have factored this problem, we would have gotten x equals negative 11 twice. So that's a double root for us. Number 4, I would really like you to pause the video and try this one, and then I'll put the work up. And actually, please do that instead of just fast forward, because it helps you to try this problem and make sure that you know what you're doing. Hopefully, when you got to number 4, I would like you to have at least gotten to this point right here. Look here. Hopefully we can all get to this point. And this one's a little bit different than our last one because we don't have a perfect square, do we? Or a 0. So when you see the square root of 56, you would hopefully know that you need to break that down. So ignore this side for a little minute. When I break down the square root of 56, it's 4 times 14. So I would have negative 4 plus or minus 2, square root of 4 is 2, root 14 over 4. If that confused you, let me just show you. The square root of 56 is root 4 times root 14, so that's where my 2 root 14 came from. So now, if you remember when we've talked about reducing before, I have to look in these three spots in order for this to cancel. I will never, ever, 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 ever touch this number under the square root. That will never reduce. So we leave it alone. It's in lowest terms. We are not doing anything with it. So that 4, 2, and 4, I can divide those all by 2. So if you look right here, that's what I did in this step. You can see that I reduced each of those by 2, and then I wrote my answer as x equals negative 2 plus or minus the square root of 14 over 2. This is our first example of a problem that has it still in square root form, and really our only one we'll do today. And so if you're wondering where the two answers come from, remember, one answer would be negative 2 plus root 14 over 2. The other would be negative 2 minus root 14 over 2. So that's where those two answers come from for this problem. Number 5 then, they all kind of start the same, so they look similar. I need to put this equation in standard form. So I'm going to add 13 to both sides. X squared minus 4x plus 13 equals 0. Again, I would identify A, B, and C. So A is 1, B is negative 4, and C is 13. X equals opposite of B, so 4 plus or minus the square root of B squared, negative 4 squared, minus 4 times 1 times 13, all over 2 times 1. As I continue to reduce this, negative 4 squared is 16. Negative 4 times 1 would be negative 4. Negative 4 times 13 would be a negative 52, all over 2. Now, I'm going to go ahead and keep reducing, so I'd have x equals 4 plus or minus 16 minus 52 would be a negative 36, all over 2. In advanced or in intermediate algebra, this is where you would have stopped your problem and said no real roots, because we did not know how to take the square root of a negative. And that would have been our answer. Lucky for us, we're so wise now after visiting Imaginary Island. So now we can actually take the square root of negative 36. We know that that is plus or minus 6i. Square root of negative 36 is 6i. So as I look at this problem and wonder what my next step is, I can't actually add a 4 to a 6i. They're not like terms. I can, however, reduce them. So when I'm looking to reduce, I am looking at this 4, I'm looking at this 6, and I'm looking at this 2. Because the 6 is being times by the I, that's why I'm able to reduce it. So I'm going to reduce these all by 2. And I would then see that my answer would be x equals 2 plus or minus 3i. If you put it over 1, I wouldn't count that wrong, but we prefer not to have that. And if you're wondering where our two answers come from, remember that that plus or minus gets separated. So you also could write them separately. I want you guys to try number 6, pause the video, and then I'll put the answer up for you. Okay, so for those of you that didn't actually pause it, try it now. Actually pause the video and see if you can do it. There we go. Number 6 was a lot like number 5. You end up with the square root of a negative 16 right here, which you would then hopefully have gotten 4i. The 6, 4, and 2 all reduced by 2, so my answer was 3 plus or minus 2i. I should have shown you your graph on number 5 also. But remember that when we have an imaginary solution, our graph does not cross the x-axis. Here's the x-axis. If it goes up, it's above the axis. If it goes down, it's below, because it's not going to actually cross it. Hopefully you remember doing some of the quadratic formula from intermediate algebra. If not, this might have been a good enough review to get you started. But remember, it is something we can use for every problem.